can put a video on the web of this webinar. Yes. For the sake of the recording, I want to say that we would like to have individual sessions with our customer districts 3, 5, 7, hopefully 4, and see if anything pops up in 11 to help with the modeling of their freeways. And right now, I will actually turn to Servet, and Servet will take over and show a little practice demo, all of which is covered in these slides. These slides are part of the release, and they also can be downloaded from our website. Now, Servet, what do I need to do to make you a presenter?
So do you see my screen?
Yes.
All right. So we're gonna make a big section, a section in the US 101, which is in Santa Rosa, and it has a merging with US 12 there. So we're starting creating a new project here. On the new project, we are going to put the scenario name. Let's call it, for our case, US 101. We are going to introduce the different vehicle types. So for the sake of our demo, we are going to have two commodities. Let's call the first one to be car, just simple car, and the second one to be trucks. It's three equivalent of cars. And we are going to set our simulation timing. So let's assume it is from midnight until 8 a.m. And once we have that, we are ready to go and create our sections. So our first section will be from the 6th Street, and it will go until the 5th Street with a length of 0.05 miles. So as you see here, we can determine how many managed lanes or how many auxiliary lanes we have, as well as general purpose lanes. So in our case here for the demo, we are going to start with 3 general purpose lanes and no auxiliary lanes. We define the capacity of each lane about 1600, a free flow speed of 65 miles per hour, and the jump density of 180 vehicles per mile. And then we can introduce our traffic demand. We set as a update period of about 60 minutes, so 1 hour. And we are able to input the demand from, for example, copy paste from a spreadsheet or from another scenario, another network that we are making, from another project. So in this case, we are going to obtain from a spreadsheet, as we see here. So I'm going to copy these and paste these values here, as we see. And then we can add a new section. So the new section will be to the westbound 12 off-ramp. I'm going to have a length of 0.11 miles, and I'm selecting copy from the current section. The reason why I'm selecting this is because I am able to obtain automatically the previous lane properties that I had set. So the capacity, free flow speed, and the jump density. So we click on the on-ramps and off-ramps, and we would like here to have the westbound 12 off-ramp. So I click add off-ramp. This off-ramp is going to have 1 general purpose lane, and I'm defining the off-ramp to have a length of 0.2 miles. So I select OK here. As we see, the off-ramp on the UI is created. We click here, and we define the properties of this off-ramp. So I'm defining to have a capacity of 1400, again 65 miles per hour as a free flow speed, and 180 for the jump density. And we are going now to introduce our off-ramp traffic split. I'm defining the update period again 60 minutes, so every 1 hour. Also, as you see here, we have percentages of cars and trucks, But in the future, we are going to have a tool that will generate split ratios from given flows. So right now, I'm going to give just the split ratios, and I'm going to copy and paste them again from the spreadsheet and put them here. And we have them here. Then feel free also to interrupt if you have a question, by the way.
Quick interruption.
Yeah.
So what Servet is showing right now, these are all features that were present in the previous release. These are sort of geometry defining features. It is a lot. So there are a lot of details here, and we're going pretty quickly, but please feel free to interrupt with any questions that you may have.
So the only comment I have is maybe the sources of your data. Was that PEMS?
Well, the source I observed some data from PEMS as well. I use I extract some data from detectors, but they are not like completely realistic. I'm using right now them just for the sake of the demo. They are not completely realistic, but they are not completely also like out of scale.
Okay.
Data sources can be anything right now, as long as you have something. If you don't have data for certain ramps, you can fill in some empirical data from your own head if you know what's going on approximately. So data, and like Servet was showing, the periodicity of data also, if for instance some data are lacking, you can put some constants if you just don't know what's going on, but presume that approximately it is this.
Okay, so for the Caltrans future users, to the extent you understand and are a user of PEMS, and your detection is good, obviously, which is improving due to Senate Bill 1, hopefully, that is one of the data sources that you will have to depend on, because the model is only as good as the data you put in it, right?
That's
Yes.
right. And this right now is sort of data source agnostic, but it will have sort of PEM specific connectors that will allow us to get data and process data from PEMs. As Servet also said, the split ratios, we're entering them directly, but eventually we'll have a piece of the tool that can translate from the off-ramp flows that we get from PEMs into those split ratios.
Yes, for instance, I know that in District 5, they use FreeQ, and in FreeQ they specify off-ramp flows. So this will be taken care of, and they will have the means to put in those data from their existing FreeQ models into OPT, and split ratios will be computed for them. So go on, Servet.
Yeah, thank you, Alex. So I'll continue now by adding another section, which will be from the westbound off-ramp to the 3rd Street there, which will be an on-ramp there, and this will have a length of 0.3 miles. Again, we extract everything as previously, the capacity, free flow speed, and jump density. And I'm making, again, a new section from the on-ramp, where will be the beginning of the on-ramp, to another on-ramp.
And when Servet is making the new section, there is an option, choose defaults or choose from the previous, choose data from the previous section, so that you do not have to retype it all the time again.
That's right. So now in this section, I'm going to create now an on-ramp. So I click here on-ramps and add an on-ramp. I would like this on-ramp to have just one general purpose lane with this specific length. So I'm clicking OK here. As you see, the on-ramp is created. I click here. I define what I want to be the capacity of the on-ramp. So I set 1400, 65 here, and 180 as jump density. And then I introduce the traffic demand in the same way that I introduce the traffic demand for the main line. So I can copy paste the values from a spreadsheet here. Copy them and paste them here. So now we have also the traffic demand. So in the same way that I made all these sections and on-ramps and off-ramps, any section can be made. So in order, because the network is a little bit larger, I'm going to skip to the already existing one that we have uploaded there. So where we were left was here. So we are going to have another section that is going to have the on-ramp with 2 lanes here in this case. And then it's going to be another section with 3 lanes here and then on-ramp, and the end, and the last part, the last section where we would like to end our network. So once we have made this, we are able to create a route. So we just right-click here on the routes, click New Route. We can put any certain name. So test route 101. So the first one, and I can click any of the origins that I have. So as you see here, these are the road sections. So I can click any of the origins. For instance, I am clicking here to start on 5th Street, and as a destination, I am selecting the last section, which ends at the Bakers Avenue on-ramp. And here we have all the road sections that are in between. So I'm here and I'm ready now to run the simulation. So I just click run simulation. As we see, the simulation is running. And now our reports are generated. Initially, on the scenario, we see the total number of vehicles that have been generated, how many cars and how many trucks. And if we go to the test route that I created, we are able to have our contour plot. So as we observe here, from around 3 to 6, there is a bottleneck here that is due to an on-ramp, and specifically this bottleneck is due to this on-ramp here that we have. And as you see, it's from 3 until 6, and after 6 the speeds are increasing. And we also observe what is the flow profile, and as well as what's the number of vehicles in that section.
Show what happens on the on-ramp.
Could you? Yeah, I was gonna say, could you show us the demand coming from the on-ramp one more time?
For sure. Yes. So the traffic demand is this one.
No, show it in the plot.
In the plot, for sure. This one here. This is the profile of the traffic demand.
Okay, hold on. Maybe the other one would be easier for me to see, because so where is the ramp demand here?
The ramp demand is this one that you are observing here, this plot.
Oh, so you're actually, the on-ramp is adding 1,300 to 1,400 vehicles per hour?
That's right. That's right. And specifically, these are the values that I have set here.
Just to clarify a little bit, if you see in the tree on the left, all of those are mainline segments, and every segment can have on-ramp and or off-ramp. So you see, he is now expanding the segments, and you can see the on-ramp that is within the segment. So when you highlight something in the left tree, you get the plots for that particular link. Right now, he's highlighting the on-ramp of one of the segments, and he gets those plots.
Okay, so I don't want to be the only one asking questions here. So I'll
okay, I have a question. This is
ahead.
Diane. I think it might be to clarify parts that the demand is for that particular ramp.
Well, it is for the particular ramp, because if I click on another ramp.
No, I realize that it is, but I mean for the future clarity.
Well, we can easily put a header there.
Yeah, change the header.
Yeah, I think that would.
Yeah.
Question is posed what about the mainline demand?
Right.
So I think that would be useful. That's all.
I agree. Upstream of what I'm trying to do, just so you know, is try to make sense of your speed contour. So upstream of that on-ramp, what was the demand?
Upstream of that on-ramp,
Yeah.
well, there's like so we have the baseline demand that we set here. So then there's like an off-ramp, so there are vehicles leaving. And well, we do not have a plot that shows what is the demand there, but we have the plot.
Servet, what is what's the upstream flow? Basically upstream of the on-ramp. And if you click on westbound 12 off, this will be your westbound 12 off to 3rd Street. This one. So this will be your flow in the general purpose lanes that you have.
Okay, so we are having 2,500 vehicles total on the 2 lanes, right? And we're adding 1,300. So clearly we're going over the max.
Enter your access code or meeting number followed by pound.
Okay, I'll repeat the question. So if I'm reading this correctly, we have 2,500 vehicles upstream of the on-ramp. You get another 1,300 in the on-ramp itself, so you get to 3,800.
Well, there's also another on-ramp here, which also adds some. So there's like, it was this on-ramp that I showed you before, but there's also another on-ramp here.
Right, but the bottleneck starts on which on-ramp?
But the bottleneck starts on this on-ramp here.
Yeah.
So
so it's able to take the first on-ramp without any congestion?
in
right.
this case, Tarek is correct that the flow on the segment, 3rd Street on-ramp segment, that already includes what came in through the on-ramp.
I
3rd
see.
Street on-ramp.
So it was 1,200 or 1,100 and got 1,300.
So it went up here to 3,500. You see the green line is 3,500. That includes the 3rd Street on-ramp.
And we have how many lanes here?
We have 3 lanes.
have 3 lanes.
So we can fit them in, and then when the next on-ramp comes, we no longer.
The next on-ramp comes is the eastbound 12.
Okay.
And then the flow downstream after the eastbound 12 on-ramp is the eastbound 12 segment. So just to clarify, can you show the segment in the configuration, Servet? Okay, so when you look at the segment flow, so that's the one when the blue segment is highlighted, that is the flow that exits the segment, so through the main line, so the downstream edge of the segment.
Oh, okay.
Whereas the flow of the on-ramp is the one that exits the on-ramp.
Okay. Get it. I'm just trying to make sure I understand the speed contour and that it makes sense. And
Tarek, when you look at the, Sarah, go back to this mainline flow. You see how the green line, this is the total number of vehicles, it reaches this capacity. It reaches the total capacity.
Right.
This is the bottleneck section, and it operates at capacity. But the number of vehicles in this section goes up.
Okay. Okay. Yeah, I get it. So
and then you see it starts propagating backwards.
Okay. Can we see the speed contour one more time?
Sure.
So how do I find out what the flow in that red area is?
You go into these individual links and look.
Because it's supposed to drop, right? We are in a queue protocol. So when we have a queue, it's not going to flow at capacity.
Oh, that is true. So not in the last section, what Gabriel was saying, that when we go to each individual section, it is the flow that goes out of the section. So if you go not into the bottleneck section, but a little bit upstream, go in upstream. Yeah, you see, it's not at capacity. It's
Right.
at 35, whatever, 3,500.
Right. Now go in the bottleneck.
It's closer to 5,000. So it's yeah.
It's 48. Yeah.
Okay. I'll talk to you, but I don't want to waste Caltrans's time, so I'll talk to you about that when we have a chance.
I just wanted to add, whatever plots we see here is not the full reports that we will have when the full release will be done. Because right now these are just basic plots of flows, speeds, and numbers of vehicles in the sections, and contour plots for speeds and flows. But we will also have all these VMT, VHT, and emissions calculated, and all of that. So all of these will be present. Right now, it's just for you to see how all these. The goal for this session was to show different types of plots that will be inside OPT.
Fair enough.
It will be line plots and contour plots and pie charts.
Any other question for that? All right. So as we obviously see, there is like this type of congestion. So, and this is created the bottleneck is created due to the on-ramp. So what we can do is that we can add controllers. So we can add a ramp meter. And these are I'm going to show you different type of controllers that we have. Right now, as you see, from midnight to midnight, so for 24 hours, we have the ramp open all the time. However, we can select different strategies like a linear or fixed rate to keep open the on-ramp or to close it completely. So right now, I'm going, for example, to use the fixed rate. So I'm going to put a ramp meter with a fixed rate into this ramp, and I will put the start time of it to be 3 when the congestion is present, is starting. And here's the metering rate per lane, and I'm going to use about 550 per vehicles per hour for each lane. And I'm going to click OK. As we see, it is 3 until 24. So then I'm going to say again that I want to be open from 5:30 until the end of the simulation. So I have this profile so right now. And then I go here again and click Run Simulation. So the simulation runs again, taking into consideration the control. And if we go again to the test route, we see that our bottleneck is reduced, and we have, and it's only at this certain time and area here. And we go back here to where we have our bottleneck. So we see now I set the ramp meter to be until 5:30. So as we see, we have a free flow speed around 5:30 on the main line, and then for the rest of the time here until 6, we have the bottleneck, and then the queue dissipates. And as well, we observe the same thing in terms of vehicles in general purpose lanes. So until 5:30, I have 25 vehicles there, and then it increases due to the congestion, and then it drops. And if we go now to the on-ramp itself, we observe that the flow now is limited at 1,100 vehicles per hour because we have 2 lanes. I said 550 per lane, the fixed rate. And here is the number of vehicles that are right now on the ramp. You should take into consideration that I didn't click the queue controls to override them. So we just see like they keep increasing and increasing. So what can happen is I can go again to the controller, select the fixed rate, and click queue control here. So I click OK. So now I have a fixed rate with queue control. So I go again, run the simulation. And we'll have now, because of the queue control, another profile here. And we go here on the on-ramp and we see, like, thanks to the queue control, it was limited at 75. However, because the queue propagates at the back, we have the override is not able to work because the increase of the number of vehicles now is due to the congestion that is present on the main line and not the on-ramp itself. That's why we have this increase.
Just allow me to just explain what we mean by the queue override or the queue control. Here we have some length of the ramp. So what did you set that to, Servet?
0.2 miles.
0.2 miles. So what that's saying is that we're saying that there's a sensor 0.2 miles. So it's a very, very long ramp with 2 lanes. And we set the fixed rate control until the ramp gets completely full of vehicles up to 0.2 miles. And then at that point, if you have the queue override checkbox checked, then it will go to maximum rate and try to flush the queue until it's within 0.2 miles. So here, that translates into about 75 vehicles. And so it kicks in at a little after 3 hours, and it is able to keep that queue at 0.2 miles for some time, but only until the main line completely congests, and then there's nowhere for those vehicles to go. So the queue override doesn't do anything after that increase. So this is simulating what would happen if you had a queue override in this situation.
So now, as I mentioned before, there is also another type of control which we can set, the alinea. So I'm going to remove the fixed rate. So I click delete, and I'm going to add another controller. I'm selecting alinea here. I put as a start time, I'm selecting again 3. And I'm going to put a minimum rate per lane about 300, and the maximum is the capacity of each lane for this round. So I click OK here. Once again, we have to run the simulation in order to obtain the new contour plot. So we go here. So now we see, due to the alinea, we have this contour plot. And once again, we can go and see the flow here and the vehicle queue. As we did in the fixed rate ramp meter, we can also introduce a queue override as well here. So if I select the alinea and click queue control, also we have to mention, like, where for the alinea which section we would like to have the sensor. So the downstream section or the upstream. In this case, we use the downstream in order for the algorithm to work. So now I have the queue control. I click again run simulation. This is now our new contour plot with a queue control, and once again we observe a different vehicle queue thanks to the queue control that we selected.
And now, Servet, please make the ramp longer. Right now, what is the length of your ramp?
The length of the ramp is 0.2 miles. How much would you like it to be?
Make it 3 times longer.
All right. So we make 3 times longer.
Yeah, and then rerun the simulation. So because queue override is your storage capacity of the ramp.
Yeah.
You see?
So we see also here the contour plot changed, and as well this one will change as well. In the future, we have not yet implemented how it's called managed lanes policies. However, if we add, for example, a managed lane here, and I try to run the simulation. When we are going to have the test route, we will be able, when we make our managed lane policies, to have as well plots for the speeds in managed lanes and flows as well.
Yes,
But
right now they're blank because there are no vehicles in those lanes.
Can I point out one thing?
Sure.
So if you collapse on the left-hand side the top level scenario,
This
right?
one?
Yeah. So right now the way Servet has shown it is that we have one scenario and we're modifying that scenario and rerunning. So when you rerun and you've modified, then the old results that you had get erased, and that's not what we want. We want to be able to run multiple different scenarios with different types of ramp metering and without ramp metering, and then make a multi-scenario comparison. So ultimately, the way you're going to use this tool is that you have, let's say, one scenario which is with no ramp metering, and then you clone that scenario, you make a new one, and you put one type of ramp metering, you clone it again, you make a different type of ramp metering, and then you want to compare all the different ramp metering styles. You'll have several scenarios here on the left, and we'll have a button that says run all scenarios, and then we'll be able to do a sort of a project level reporting. So that's ultimately how we'll be using the tool.
So these are pretty much right now the different functionalities that we were able to add, and we added. So if anyone has any type of question, feel free to ask regarding that.
I'll do it offline. This is Stark, so that Caltrans has a chance to ask.
Yeah, I'd like to urge everyone to ask any question you might have.
Is one of the advances with respect to FreeQ is here you can compare different ramp metering strategies, and you obviously see that they produce different results.
And one thing that we would like to know is what is important to people in terms of our next steps. What performance metrics people are looking for in terms of emissions and so forth. Alex is going to talk a little bit about our next steps now, but these are the kinds of inputs that we're looking for, so that the tool can be immediately useful to people.
Yes, right now basically we are entering the months when pretty much in July, August we can still kind of address your wishes, but if you miss the opportunity, then you miss the opportunity. So this is what is going to happen between now and September. On the model, there will be a modeling, configuration, and reporting development effort. On the modeling, there will be managed lane policies added, and that will include HOV, HOT, and also shoulders. So, for instance, in District 5, they want to have a time when they open shoulder during the rush hour and then close it again. Speed control for those who will be trying something out with that. Off-ramp conversion to split ratios. This is what I mentioned again. People who have FreeQ models, they have off-ramp flows instead of split ratios, and we will have an enabling button for them to convert those flows into split ratios so that they run OPT simulation seamlessly. Performance calculations aggregates. This is what I said. Right now, you just see a handful of plots, but in reality, there will be many more plots than just that. So, including vehicle miles traveled, vehicle hours traveled, delays, and so on. events, this is, we talked initially that we want to have scenarios with events such as lane closure. Maybe somebody wants to model an accident, or somebody wants to model a road work when there will be a lane closure. So these kind of events, when you specify the start and end time and say that something will happen with the parameters of your network, that means reduced number of lanes, or added number of lanes, or closed off-ramp or closed on-ramp. So the effect will be seen in the simulation result. So, like I said, instead of all these all-hands meetings when too many people are present and some people are interested in one feature, some are interested in the other, we will work individually with districts. And right now we have contacts with District 3, 5, 7, and we hope to get somebody from District 4 because it's a big district and I think they will benefit from this tool. So this is a specific thing that we aim at doing. We will do it ourselves. We are reaching out to engineers and districts. But if I omitted somebody, but you want to participate, please contact me, contact Diane or Tarek or Gabriel, so that they put us in touch. And we will see what corridor you have. Basically, give you a concierge treatment, as they say in Mercedes-Benz. So, configuration. In the configuration, what will be added, the major addition will be, right now, you look at individual links, but we will provide the map of the network. By map, don't be confused. This will be not a map like on Google Maps, because you build section by section without indicating what the geometry of these sections really is. But it will be a schematic. It will be more like a subway type of a schema, because you have multiple freeways. We are trying to figure out what would be the best ways to display it. But you will see the map, and where the link that you are looking at belongs on that map. This is what you're going to get in terms of the map. User settings. By user settings, this will be a special window where you can set your defaults so that you do not have to retype them all over again. So right now you may add a new link and you have some parameters. They're not quite there, not what you want. So you will have default settings where you specify those, and these will be your defaults. When the new highway capacity manual comes out, and it will provide certain numbers, you can take those numbers from the new highway capacity manuals and put them as defaults, or whatever your district uses as defaults. Event editing is obvious. Basically, this is how you set up the event. Lane closure from time X to time Y, and so on. And on the reporting side, like I said, there will be many more plots, but also there will be an export button. And the export will allow you to export the data in spreadsheets. So this will be pure numbers. This will be the numbers that are generated for flows, speeds, vehicle counts or densities, also VMTs, VHTs, delays, emission performance metrics. So this will go into a spreadsheet. Or if you want to see pretty pictures, we will export these plots that you see inside the OPT. But if you want to generate a fancy report, like a PowerPoint presentation or something, there will be means for you to export those plots. So that's what we are up to. Most of these features will appear by September. so that the rest of the period of this project we do testing, we work with modelers, with district models, and so on. Discussion, comments, questions, wishes, suggestions. And everybody is silent. When everybody is silent, it's very convenient for us to understand whether people agree or people don't care. So please speak up.
Okay, let me try it a different way. This is Tarek. Can we go through the Caltrans folks and see, one, if they know how to get data that is required based on today's demonstration, be it number of lanes, length of the segment, flow on the segment, and so on and so forth, capacity of a ramp, data that's really, if you don't have it, you cannot use OPT. I don't know if you want, and Diane, you want to go district by district, but I'd like to understand to the extent to which people are comfortable at least getting the data that's needed to use OPT.
And I also have a question of attendees. Have you used FreeQ in the past? Because I think anyone who has used FreeQ would have no trouble with OPT because it's the same format and the same system of entering data. So, you know, I don't want to call on anybody. Will somebody volunteer and speak up? Otherwise, I might have to call on somebody.
Let's start with Kalen, since I know her. Oh, she doesn't want it. Okay.
Okay, well, you know, I hope some of you will, you know, the request, the overwhelming request from people in districts was an easy to use tool that was similar to FreeQ, which is no longer supported. So this is your opportunity to help, you know, develop the tool. And, you know, as was noted, as Alex noted, you have a few month window to make suggestions, and then the tool will be finished. So, you know, we do need to know that the project, the district three, the 3, 5, and 7 projects will be quite interesting. But does anyone have any questions? Or are you puzzled? Or you know, is there some feature that you didn't see you want?
Hey, Diane, this is Tyler Monson from GriSci. Hey, back in May of 2019, wow, a year ago, I sent a note to Tarek about a recent purchase that we made of national performance management data from INRIX, and I think we have data up until through this year, and working on getting additional data. How could that be incorporated into this, or does that help the data manage or the data input question?
I can try to answer that. So INRIX gives you great or relatively great speed data. We've done comparisons between INRIX and PEMS and floating cars, and INRIX is actually more accurate than PEMS from a speed perspective. INRIX doesn't give you volumes, but what you could use INRIX with is look at the speeds that it produces for the time periods you're simulating and compare it against the speeds that the model is producing. In fact, that's how we do when we manage microsimulation, mesoscopic simulation, or even OPT. The truth is it has to be able to simulate or replicate within reason what you're seeing in the field. And that's the trick of calibration. So for instance, sorry, Servet, is that Servet
Yes.
put in certain assumptions for capacity on the mixed flow lanes, on the general purpose lanes. I believe you put 1600. You might find
That's right.
you may find that your speeds are faster than what the model shows. And here comes the calibration process of you saying, well, maybe my capacity is actually higher than 1600. Maybe it's 1700. I know people who use 1800 and 1900, although I tend to start having doubts about whether we can sustain 1900 or 2000 vehicles per hour per lane. But anyhow, so if your speeds are faster, you may play with capacity to make it 1650 or 1700, rerun the simulation, and again compare it to the INRIX speeds. And INRIX does give you speed contour data if you have INRIX analytics. If not, you have to download it and do the same thing until you get to a point where you feel that the model reasonably approximates what you're seeing from INRIX. What INRIX doesn't give you is volumes, and that's where PEMS, I still call PEMS the best volume book in California, because almost all other volume data sources are less accurate than PEMS, despite the fact that detection is still up and down depending on which district you're talking about, but it's still by far the best data source for volumes. So if you want to check volumes, you go to PEMS. If you have access to national data, which is currently INRIX and will be here data in the next year, then you can compare speeds. If the model, and I know it's a very long-winded answer, but if the model is not calibrated correctly to reflect normal conditions on the freeway, then it doesn't really matter what scenarios you run because you haven't calibrated it correctly. I don't know if you agree with that, Alex, but that's my opinion.
I would like also to add something, because you mentioned the capacity. So for example, I said the 1600 vehicles per hour per lane because I had observed from PEMS data on that section what is the discharge flow when we have a present queue, and it was 4800. So that's why I said for 3 lanes. So that's why I said 1600. So thanks to PEMS data, I chose this kind of capacity per lane as well.
I think there's an art to it, Servet, because when there is no queue, you will observe 17 and 1800.
Actually, for that section, when there was no queue, it was like it was about 3,000. It was the demand practically equal with the discharge flow. But when there was like a queue present, the discharge flow was 48.
Okay. 48. The way I believe you guys did it, Gabriel and Alex, before, is that you had a maximum capacity that you looked at based on looking at PEM's flow rates and seeing what's the highest it was able to sustain. But this is just a small example. It could be that for the managed lane you use what Caltrans says, which is 15 to 1600. And for the GP lanes, you may use 1800. But you're right, it depends on the freeway. If the lanes are narrow and the demand is not as high except during a certain hour, then maybe it is 1600. I'm just saying, if you come up with a speed contour like you just showed us, that's different from what INRIX shows you or what even PEMS show you, then you need to do some more work to calibrate the base model before you run scenarios.
That's right. That's a good use of the speed data, and I think that eventually we will get to what are the methodologies that are going to apply to calibrating this, because we haven't addressed that at all yet. But I just wanted to say that we have some questions in the chat. So maybe it's a good time to go through those in the.
Actually, I have a quick question. This is Mark from Mark from District 7. I'm looking at you're inputting the demands for the segments and on-off ramps. I ran into some problem when I was modeling. I was looking at some models for some of our projects. The demand that we get from PAM, that those are if there's no bottleneck or no congestion, if the freeway is not oversaturated, then that would be a true demand volume. But if the freeway is oversaturated, and the PAM's data that we get, the flow data we get from PAM, those are only served volumes. They are not actual demand volumes. And how do you address that?
So you point to the right problem. Again, want to separate the two questions of modeling and data. So if how do you get demand data if you have ramp metering and your detector downstream of your ramp metering only measures metered flow? So well, you use it, you use demand models or something, or you guess based on your empirical experience of your district what the actual demand is. So there are no miracles there. So the tool cannot figure out the real demand for you, right? So I guess what is the common practice? You either use the demand model or you observe certain flow and then say that, okay, I also observe certain queues, so hence my demand must be such and such.
I would like also to add something to that. In order to find what the demand is, what the actual demand is, you can go at a further upstream section, for example, on PEMS, which is uncongested, and then you can observe from the detector data what the demand is. So you can start by selecting a section which is upstream of the section you are interested, and try to use that as something initial for your demand.
I have a actual a couple projects that we are looking at, and there's a congestion, and the congestion it's all the way to the beginning of the freeway. And there's no area, there's no point on the freeway that is not that's not congested. How do you do it? How do you come up with actual demand?
Let me chime in. Can you tell me which freeway you're talking about? Because I'm very familiar with LA.
91.
91. Okay. So if you are trying to model a period, let's say 3 to 7 p.m. Yeah, PM peak, 3 to 7 p.m. or 4 to 6 p.m., however you define your PM peak period.
The PM peak,
And clearly, whether it's the 91 or the 405, you have congestion the whole time. So yes. You're stuck between a rock and a hard place here. So right. What you should do is start your modeling before the bottleneck occurs. So let's say you're doing from 3 to 7, try to do it from 1 to 7.
Right.
Because then at 1 o'clock, you may not have the queue all the way to the end of the freeway, to the beginning of the freeway, and then you'll see the queue building up over time till it reaches that end. But
that's right.
But it's very tricky to choose a section that already is in the middle of the queue. I would start with a period before the queue starts. And by the way, your question about demand versus flow is a very good one, because the two types of models out there contradict each other all the time. So a travel demand model like the SCAG model or the Metro model in your area, if you say demand is 1 million, they will put the million on that link, even though it's physically impossible.
Right.
And they will tell you that the speed is 0.1 miles per hour. Now, we all know this will never happen, right? Nobody is going to stay 10 hours to move 1 mile. But because it does its analysis link by link as opposed to flow. So that's one type of model, and believe it or not, that's the model that's used for air quality conformity, and everybody knows its shortcomings, but it is based on demand. The traffic models are more based on flow. What is the actual flow? And as they showed you in the case, the demo that they just showed you, you had unreasonable backup on the queues, on the ramps. So the first one that they showed you where they had a huge rise when they put ramp metering on the ramps, that would mean the cities would call you and say, what the heck are you doing? The vehicles are completely stuck at the ramp intersection, and it's creating
Tarek.
havoc in our cities. Go
Let
ahead.
me just interrupt you there so that we're on time now.
Okay.
I just wanted to quickly go through these questions. There are a bunch in the chat. So I'll just go through them very quickly. So MM says, is this tool capable of modeling multiple segments in the same model? The answer is yes. I think what you're referring to there may be multiple freeways, and we've not demonstrated here how to create multiple freeways, but essentially you can do that. So there's an off-ramp, you can make a connector into another on-ramp on a different freeway and then start building another freeway. So the answer is yes to that. Are the presentation slides available after the meeting? Yes, they will be on our website. Is that right, Alex?
They're already on the website.
They're on the website. Are the background documents for the alpha version of OPP available to study? We haven't done much documentation yet because it's a little bit difficult when the UI is still under development and changing a lot to start on the documentation. So there is not much documentation on the UI, so the front end, but on the back end, on the simulation engine, we have some academic publications, so to speak. So we can we'll put links on the website for that. Is the ease and time to model a corridor similar to FreeQ? Yes, I would say it's actually easier than FreeQ because FreeQ didn't allow for this cut and paste of demands and flows into the tables, which this does, and so the simulation is very quick and building is very, very quick. So I would say that it is quite comparable to FreeQ. So mainline VDS max observed flow, should it be used? Well, yeah, this is a
calibration
modeling question that is a good one. So should it be used? Well, depends, right? What is causing the bottleneck? Is it a flow bottleneck? Is it a weaving bottleneck? Is it an on-ramp bottleneck? So these are modeling questions that go into how you put the data in.
And also whether it's a bottleneck section, because if it's not a bottleneck section, then maximum observed flow does not really reflect the capacity.
This was a question from Robert Forwerda. I don't know if Robert wants to expand on that, but otherwise those are the questions that were in the chat.
I would like to invite everyone to contact us individually if you want to have an extensive discussion about your particular modeling questions, because we are interested in it. We may be able to help. So, for example, with somebody from District 7 was talking about how to model the congested segment. Yes, things like that we can discuss individually. Please reach out. Feel free. Do not be embarrassed or shy we are out there for you.
So I have one more question. Is there a maximum number of links with on and off ramps that people simulate here?
We do not impose any limits.
In fact, one more thing that we didn't show is that each segment can have multiple on-ramps, multiple off-ramps. It can also have right-hand ramps and left-hand ramps, both on and off. So you can have ramps that are exclusive for the managed lanes. So yeah, there's a lot of flexibility in how you configure the segment.
And just to wrap it up, in this list, you see these are our planned future meetings. It's one in September, one in November. We leave December just to all the finalizing and back and forth questions, answers, and last minute issues. So, but like I said, we will reach out. Thank you for answering these questions. I copied everything from the chat that was asked. We will address also these questions in writing and put it on the website, the answers to those, without mentioning the names of those who asked. So don't worry. And like I said, feel free to reach out to us. We will also reach out to District 357, and we'll try to see if somebody in 4 is interested in 11. And if we have forgotten somebody, let me know.
Yeah, I'd like to encourage all of you to reach out to Alex. You can do it through me or directly with him if you have questions or want help with a project. And you know, you can download the software website. And Alex, you successfully recorded this meeting, right?
Yes, and this recording, this meeting will be on the web as well, starting tomorrow, I guess.
Great.
Yeah, for those of you who haven't downloaded it yet, just swallow hard, download it, and start playing with it.
Yeah, and I just want to point out, you do not need IT to install it. If you follow, you can install it yourself. It does not require administrator installation.
That's great, Diane. That's very good.
Okay, well, thanks a lot, everyone, and stay tuned.
Thank you for joining, and
thank you, everybody.
Bye.
Bye-bye.
Great one. Bye-bye.
Thank you. Bye-bye.